Hello everyone, my name is Puya Atai and today I'm here to present New Mycelia, a software reference architecture for big data systems. In this presentation, first I will go through a little bit of history and background of why I'm here and why I'm doing this. And then I will go through discussing why a software reference architecture could be a good solution for challenges in big data domain and why I have chosen New Mycelia to be this way. So let's get through this. The genesis of big data in my life, my journey into the big data started from 2016, the end of 2015, roughly November 2015, where I found the topic very interesting and I started to do a lot of research on it. And then eventually I chose it as my master's thesis. I've been since then researching in a lot of different aspects of big data, specifically big data methodologies, stream processing, batch processing, and lately for my PhD, big data software architecture. As I went through and captured a lot of information about big data, and I read a lot of papers and white papers, and I went to a lot of conferences, I realized that even though big data is a hyped concept and a lot of companies have invested a lot in it, the success rate has not been that promising. It has been estimated by a few organizations such as Gartner, MVP, and Venture AI that 80% of big data projects have failed, and that's quite a big number. So, given this piece of information, I realized that one of the great things that I could do for the course of my PhD is to try to address this issue. So I started reading a lot and trying to understand why these projects fail and what are the root cause of these problems. A lot of things came up, and through several systematic literature review, I realized the biggest things are probably the complexity of data engineering, the system development, the talent gap. We don't have a lot of good data scientists or data engineers out there. The culture of the company and if they can absorb that complexity, and how they see and address value in a big data endeavor. Given all of the problems that I just mentioned, architecture seemed to be a good solution to address system development, communication, and partially organizational problems. And architectures, being the earliest point in decision, capture all the business requirements and all the facets of the project, of the system to be developed, and try to inject them with patterns and solutions which will allow for those requirements and which will allow for that system to scale. And being the earliest point in decision making, this is where you capture mistakes that are very expensive a little bit down the line. So, because I was doing an academic kind of a approach to this problem as a process of my PhD, I quickly realized that concrete architectures, which is usually referred to as a design of a system or an architecture, are usually revolving around stakeholders and the domain and the context in which they are developed. And that was not good enough for me. I was looking forward to solve the architectural problems of big data without having to deal with the stakeholders or things that are related to a specific setup or environment. And that's where reference architectures entered. Reference architectures are better academic endeavors because they do not have any clear set of stakeholders. They are at the highest level of abstraction, and they do aim to address more architectural qualities than actual concrete architectures. A lot of successful applications today in the market are the result of a good reference architecture. Open Framework, for example, has created many standards and many reference architectures that are now prevalent. So a reference architecture is a very good high-level artifact to address some of the issues of big data system development, communication, and organizational issues. So my mission is to create a domain-specific big data reference architecture, and I am trying to create a reference architecture that designers or software architects can absorb and create their own concrete architecture out of it. Given that I've done my both my bachelor and master in software engineering, and I've been in industry for more than 5 years, I have worked with a lot of technology, and I have also published a lot of papers in a book on big data software engineering aspects, and also general software engineering concepts. So being a software engineer inherently for so many years, I know the value of maintainability and scalability. And as today's market is rapidly growing and requirements are evolving very quickly every month, a software architect or an architecture should account for the evolving nature of software for today. So if I was about to create a reference architecture for big data systems, traditional monolithic or n-tier architectures would not suffice. And that's for the reasons that they cannot scale and account for the rapid evolvement of the industry. To address those issues, I absorbed some of the concepts from microservices, event-driven, reactive programming, and domain-driven designs, and created Neo Mycelia, which is the first of its kind for big data systems. Neo Mycelia is a decentralized and distributed, event-driven software reference architecture for big data systems, with a lot of attention to modifiability, performance, scalability, fault tolerance, and extensibility. I have also absorbed concepts from other school of thought, such as data mesh and service mesh. As you can see, every big data system usually goes with a stream processing and batch processing. I have also studied a lot of other reference architectures for big data, and also other architectures for big data, such as Lambda, NIST, and so on and so forth. To the best of my knowledge and based on all the researches and systematic literature reviews that I've done, currently a decentralized and distributed reference architecture for big data does not exist. And that's why Neo Mycelia really shines. Neo Mycelia makes use of service mesh, the event backbone, the API gateway, which is a very common pattern in microservices kind of an architecture, service discovery, another common pattern in microservices kind of an architecture, and also a semantic layer, which is a metadata layer for big data systems. A lot of times you do not see a mention of semantic layer, and metadata and semantic layer plays an important role for big data systems. Aside from that, we've had a lot of mechanisms to try to increase our fault tolerance, and this architecture has been designed in a way that no module or no mesh depends on another mesh. So you can take out one mesh without affecting any other parts of the system. That also means we have increased fault tolerance. So if we had batch processing service mesh down, we can have something called a circuit breaker pattern, which would signal that, hey, this service is not available now, and this will not affect the other parts of a system. In another terms, we do not have the experience of a monolith in which, where one component breaks, the whole system does not function. So we achieved I think in this software architecture, something gracefully decentralized and distributed that can account for requirements and that can address quality attributes of the market. We used NeoMycelia in an actual environment, in practice, in an Oakland-based company that has got 15,000 clients all around the globe. And we managed to achieve very good results. So if I go back to the previous slide, that's me and my colleague at Oakland University of Technology. We managed to replicate. So the way we evaluated this software reference architecture was through prototyping. We created a prototype, and then we applied ATAM, architecture trade-off analysis method, and SAAM, an attribute-driven analysis, and a few other methods, a few other quantitative methods to understand the feedback from our system. The nitty-gritty details of how we developed the system and where it was launched is out of a scope of this presentation, given that I only have 15 minutes. But the event backbone we used was Kafka, and I refused the term event bus because event bus is usually not a decentralized and distributed IT artifact. So event backbone that we used was Kafka, and event backbone itself had the event archive, which came with Kafka. We tried to stress test this system, and we went all the way to 100,000 transactions, and we saw that it gracefully scaled. We could throw more at it, and we went and we had a little bit of fun of trying to increase the scale, and we realized that no matter how much we do, we may sometimes have kind of a tail latency issue or networking kind of a disadvantage, but overall the results were very promising. We also realized that the organizational setup in which we were testing our reference architecture required a privacy layer. So all we've done is that we sort of copied some of our code for our semantic layer, changed our systems and software, and it had like kind of a policy layer in which we would know, for example, if certain drugs cannot be prescribed in certain countries, and that would happen real time before we could stream process something. So overall, we could add other service mesh, or we could have a lot of different flows. This watches is not like a logical view of the architecture, it's the structural view of the architecture. So that was really all about it. I am working on something even better than this. I'm looking forward to incorporate more of a data mesh, which is a very new term, and most people that I talk to don't even know about it. The term is probably 1 year old. The first time it's being used was the end of 2019, if I'm not mistaken. And I'm also thinking of trying to address some of the tail latency issues, and trying to kind of increase the OS overheads, such as context switch as well. But overall, this has been very promising, and in the next works we'll try to incorporate more of data mesh into new mycelia, which will be a big part of my PhD as well. Thank you all for listening. If you wanted to reach out, please reach